Do you ever wonder if the crazy thing someone just told you is true? For instance, you may have heard that person declare that at some point in the near future, California is going to break off and fall into the ocean. My older brother told me that the Golden State is hanging off the end of the continent and will fall into the Pacific Ocean during the next big earthquake. Do the tectonic plates, or giant pieces of the Earth's crust that fit together and move around on the Earth's surface, really move? If so, what causes them to move? The best stories are often based on fact, so it is helpful to know what is real versus what is not. Yes, tectonic plates move, and the mechanism that causes them to move is the subject of this lesson. The part of my brother's story that is true is the western part of California, west of the San Andreas Fault, is moving in a different direction than the rest of the continent. The western part of California is moving northwest at the rate of several centimeters per year. Looking to the future, California will indeed one day separate from the rest of North America and become an island. Where I think my brother got confused is the mechanism that will cause this to occur. First of all, it is important to know that the Earth's crust is broken up into large pieces called tectonic plates. Remember, tectonic plates are giant pieces of the Earth's crust that fit together and move around on the Earth's surface. This movement can be observed and measured using GPS systems, and the edges of the plates can be detected as their edges can be seen. We also know that these plates move around with respect to one another. Earthquakes and volcanoes are the results of such plate movement. One question geologists have been trying to answer is, what is causing the plates of the Earth to move? This can be a challenging question because we are not able to get into the Earth's interior to observe it. There are several mechanisms that scientists have developed based on the observations of the plates and a deeper understanding of the inner layers of the Earth. These mechanisms operate at different points in the Earth and very well could complement each other, each assisting in moving the plate in its own fashion. Scientists believe that one of the primary forces behind plate movement is thermal convection. Thermal convection is when heat from the core of the Earth is transferred to the surface of the Earth by the mantle. The mantle is the thick, mostly solid layer of the Earth between the crust and the core. Thermal convection works a lot like a pot of boiling water, which can be seen in this animation. In convection, heat from the stove warms up the water closest to the stove, causing the water to expand and rise. Cooler water near the surface of the pot sinks to take the place of the rising water. In doing so, a current of water is set up flowing toward the surface and back down again. Using this model, the stove is like the core and the water is the liquid mantle that rotates. The plates on the Earth's surface would be floating on top of the water. These currents push the plates along according to the direction of the flow. Geologists think that this same phenomenon is what is happening inside the Earth. Liquid rock near the mantle is heated and rises toward the crust. The rock near the surface is cooler and sinks back down toward the core. This forms the same type of convection current which causes the plates to move. Scientists believe that this cycle of magma rising from the core to the crust and back again takes thousands of years to complete. At the top of the mantle, the rock encounters the thin crust, and as it pushes it aside, lava flows out from the mantle to form new oceanic crust. As this happens, the plates smash into each other, slide past each other, or are pushed under another plate. This movement of the plate, along with the upwelling of the mantle by the convection currents, may also cause secondary actions that assist in plate movement. In ridge push, the mantle wells upward because of the convection and elevates the edges of spreading oceanic plates. Because these plates are higher at the spreading center, they are forced downhill due to gravity and eventually flatten out to the ocean floor. The gravity causes this movement down the ridge, and it gives the plate a push along as new crust forms behind the plate at the spreading center. This is like those coin bulldozers at the fair where one new coin may push forward and knock others out of the way. Another mechanism that forms as a result of plate movement is slab pull. As the plate is pushed along, it may run into another plate. Oceanic crust is easily forced under another plate and back into the mantle. These converging boundaries can be identified by deep ocean trenches that mark the location where one plate is sliding under another one. As it slides under the other plate and is forced back into the mantle, gravity again works to pull it along, giving the plate another force to keep it moving. These two mechanisms are different. In slab pull, gravity is pulling on the front part of the plate. In ridge push, it is forcing movement from the back end. A third force that forms as a result of plate movement is known as trench suction. As a plate gets pushed back into the mantle, as we saw in slab pull, it is forced down at an angle. Not only does gravity pull it down in the slab pull model, but another force can act on it as well. Underneath and behind the plate, a small convection current caused by the diving crust can form and help pull the plate into the earth. It is very similar to the force that keeps a raft trapped in suction under a waterfall. This force aids in pulling the plate back to the Earth's interior to remelt. This also differs from ridge push and slab pull because it is not the result of gravitational pull. So, to recap, there are several mechanisms that scientists use to help explain the movement of the giant pieces of the Earth's crust, called tectonic plates. The force that causes most of the plate movement is thermal convection, where heat from the Earth's interior causes currents of hot rising magma and cooler sinking magma to flow, moving the plates of the crust along with them. Additional mechanisms that may aid in plates moving involve ridge push, slab pull, and trench suction. In ridge push and slab pull, gravity is acting on the plate to cause the movement. Areas where the crust is pushed upward by magma welling up are also pulled downward by gravity, forcing edges of plates back into the Earth's interior. These processes pull the whole plate along. In trench suction, a small convection current is formed by the remelting plate as it pushes back into the interior, and the current creates a force that pulls the plate downward.